Okay, so C3, question 1. It says here, use Simpson's rule with 5 ordinates to find an approximate value for that integral there. Now, what's important with integrals, integrating trigonometrical functions, got to put it in radian mode. Okay, so change that to radian, shift setup 4, so we're in radian mode there. It's really important you do that. So R is on the top, so we can answer question 1. So with Simpson's rule, okay, first thing you do is obviously notice ordinates there, so 5 ordinates, okay, of course then that means there's going to be 4 strips, okay, always one less, in terms of strips, always one less than the ordinates. So then use the formula from the formula booklet, and the height of these strips is going to be b take away a over n, okay, where b is the upper limit. So this is given to you in the formula booklet. B is the upper limit, which is pi over 4. A is the lower limit, which is 0. Divide them by the number of strips, which is 4. So work that out. Of course, you could take that 4 down, so pi over 16. That's the length of the strip, height of the strip. So first x value then, x0, okay, is the lower limit, which is 0. So we're going to put it into then sine squared x. Now on your calculator, what we'll do is, then x0 is 0, so we've got your y0, and this is your y function here. So in terms of typing that into the calculator, you're probably better off typing it like this, okay, because you want to do sine squared x, so do sine of 0 and then square the whole thing. So we've got bracket sine 0, close that bracket to 0, then another bracket then, so square, so we've got then 0, okay. x1 then will be pi over 16, okay, so that's the height of the strip. So then y1, essentially then you're going to put in here, you're going to put sine pi over 16. You don't need to write these out all the time, okay, but the answer is the most important thing. So if I go back in my calculator and change this as pi over 16, and I get this then 0.03806023374. Okay, x2 then will be 2 pi by 16, okay, so another pi by 16. So then y2 will equal, so go back here, change this to 2, you get 0.14644669094. x3 then, 3 pi by 16, so y3, so go back here, so you get 0.30865882838, and then x4 then will be 4 pi by 16, which is actually then pi by 16. Okay, so you get to the last ordinate then, the 5th ordinate. So change this then to be 4 pi by 16, and you get exactly a half, like 0.5. Okay, so when it comes to then Simpson's rule, okay, the integral then, let's call it I, right, will be from the formula booklet 1/3 times the height, which is pi over 16. We worked that out earlier. Then it's going to be the first and the last, so y0, which is 0, plus the last, which is 0.5, plus then 4 times the odd terms, okay, so the odd terms will be that one there, okay, plus so that's a y1, plus then the y3, which is that one there, 0.308, etc, etc, plus then twice the even terms, which is just this one here, okay? So this is in the formula booklet, so no need to stress about remembering it. Just use it properly. Okay, so when it comes then to working this out, now what I tend to do is I tend to work out all this bracket stuff first, okay? So 0 plus 0.5 plus 4 times then the odds, which is 0.03806023324, plus then y3 0.30865 0.82835, close bracket, plus then twice the even, which was 0.14644666094. Okay, so I've worked out all that bracket stuff, and then I'll times it by the third, by the, change that, by the pi over 16. And I get 0.14, and they wanted to 4 decimal places, 27. Okay, there's my answer there. Now, part B then, it says use your answer to part A to work out this. Okay, now what you got to remember is cos squared, how that relates to sine squared. Okay, and of course, because we know sine squared x plus cos squared x equals 1, then cos squared x will equal to 1 minus sine squared x. Okay, so you can take that sine squared x over as a minus. Okay, so when you've got that integral going on then, right, what's easy about this then is you can split this up when it comes to integrating it. So you can integrate 1 dx, take away then the integral of sine squared x dx. Now integrate 1 is easy with respect to x, you just get x, don't you? Put the limits in. Integrate this, well we've already done it, haven't we? This is part A. Okay, this is just A, isn't it? If you look back to A, that's exactly what we worked out in A, so we just put the answer there from A. Okay, and then put these limits in here, pi over 4, take away 0, take away then this, and give our answer also then to 4 decimal places to follow suit from part A. Okay, and we get this then 0.6427 to 4 decimal places.